this is like a metal thing. It's got two different metals on each side, and we're gonna see what happens when it is heated up.
Maybe if you heat one side for a little bit, then turn it over and heat the other side as well, just to show that it's not just the side you're heating that's changing.
What do we think is going to happen if there's two different metals on this strip? Can
One's
anyone?
gonna heat faster than the other.
Or one
Yep.
might
Oh,
melt.
yeah. Mm.
Maybe.
Okay, so there's option one is one might heat faster than the other. There's option two, one might melt. Any third option maybe?
They're going to split apart.
They're going to split apart, so there might be a gap between the two metals. Okay, there's three, or option four is none of the above. Who votes for A? They're going to heat up differently.
Yeah.
Okay,
I think
got
they're gonna heat up
one,
differently.
two, a few votes
So
for that.
hands up.
Who votes
Yeah.
for one of them's going to melt?
Yeah, mate.
A couple for that.
No, it's not gonna
Who votes that there's going to be a
No.
gap, so they're going to split up?
Yeah. Yeah,
mate.
yeah.
Okay, and who votes none of the above? Quite a few. Okay.
That's wrong. Your glasses.
No, you'll be able to see.
Try, Jasmine, just choose one place to heat it.
Okay.
Yep, so like the middle, and heat it on that there for a while, then turn it over in the same point on the other side. Okay, spin it over. It's starting to do it now, but pretty slowly. You might want to use the thinner one instead if this is going to take too long. There's another one
The
there.
little lower.
Yeah,
What's gonna happen?
not that one, guys.
Where
Yeah, it's
does-
starting to. If you hold it up, you can see that it's starting to actually do it, but not very obviously. So it's starting to do something. We'll see it more dramatically with the other. No, not that one. Not that one. That's it. This is a small version of the same thing. Happens a lot quicker because it's the thinner bits of metal. Okay, and the top of that blue cone, and the top of that see the blue cone in the flame.
Oh.
That's the hottest bit. Maybe further in. Yep, that's better.
So what's happening?
It's bending
Why is it bending?
because it's heating.
But
Think-
why
Well,
is
two
it
different
bending
metals
that way?
are reacting.
Yeah,
Because
but
they-
what are they doing?
They're trying to
That metal's
That's
not as-
expanding. Yeah, it's just bending.
Hang on, we got one answer over here as well.
The metal on that side is heated up.
Keep going.
It's red hot.
Easier.
So one metal heats easier. What does that mean for? This is about expansion and
Turn
contraction.
it over,
I think Ben, you were on the
then
right
other
track
end
before.
can be heated, and we'll see the other side.
Yeah, that's are they reacting and like pushing against each other?
Okay, reacting. There might be a little bit of a reaction there, but that's not what expansion and contraction is. So
The particles are heating and spreading apart.
cool. And is it the same in both metals?
No.
What's someone other than me gonna tell me what they think? Which metal, the top at the moment, the top metal or the bottom metal? Which one do we think is expanding the most? Sorry, expanding more. There's two metals in that little strip. Which one's expanding more, the top one or the bottom?
top one.
Why do
No,
you say it's the top one, Tom?
The
You're
bottom
correct.
one at the moment.
Now it's the bottom,
now-
yeah.
Yeah,
Okay, so why why do you say it's the top one, Tom?
because it's bent over more to the
It's
way.
bent more, good.
that
It's
way.
stretched more, cool. So, do you want to think what this might be used for? Where at a certain temperature you might get something bending. Any ideas what that might be used for? A thermostat, cool. So something to control the temperature, turn something on or off, a heater on or off, depending on the heat. What else? What also turns on or off depending on heat? Probably use it every morning at breakfast time is what I'm thinking of.
Toaster.
Toaster. What would that make? So when it gets to a certain heat, what happens to the toast?
Pops.
Pops, yeah.
Oh.
Cool. Okay, cool. So that's the first one. We've got another demo there for expansion and contraction.
Yes.
How could I get that straight again really fast?
Put
Put it in the water.
Cold water.
Okay, let's see if it works.
What?
Well, that's straight. Just like that. And the same, nearly. And the fact it's got a bit of a colour says Ben was right, there was a wee bit of a chemical reaction there as well. Cool. Okay, what else have you got for us?
We have a ball and a hole.
Okay, and do they fit or not fit?
Oh
or?
yeah, at the moment it fits through,
Okay,
and we're gonna heat it.
okay. Could I suggest use the tongs to hold it in just so you... Cool, well done.
So what do we think's gonna happen?
It's gonna
Someone other than me. Yes.
It's gonna get bigger
Why is it gonna get bigger?
because it expands.
Okay, so what will you observe then,
Wait.
Tom?
Like, because it can't go through the hole anymore. Or,
Hold the bowl with
Oh.
tongs.
That's it. That allows you to hold it in the right place.
So what do we think's gonna happen, sorry?
It's gonna
expand?
It's gonna
It won't
expand
fit
and then
through
won't
the-
fit through that hole. What?
Does anyone disagree?
Would you like to repeat?
Jack, could you hold the one with the hole,
I would,
please?
actually.
Thank you. Okay, so the simple, if we're going to do like a sequence, it's heating up, just making the particles move, what? Move apart, move faster, which makes them move apart so they don't collide with each other. And that makes the ball expand, which means we predict the ball will or will not go through the hole. Will not. Okay, we're at relational level now. Let's see if we can get to abstract in a moment, and I'll ask you how to get to abstract. Should we try it now? See if it fits. Still fits, so it can't be hot enough yet. If we're right with our prediction, how could we make it fit through again really quickly?
Put it in the cold water.
All right. Why do you think that would work, Ben?
Because the particles will stop moving so fast.
Cool. So it won't
Enjoy
expand anymore. It'll
Shrink.
contract.
Contract.
shrink, contract, both good words. Contract's our sciencey word, but it means to shrink.
What metal is that?
I think it's just iron, which is why it's taking a while, because iron isn't one of the best conductors, which means it also doesn't expand very easily or very quickly.
That thin wire keeps like.
Yeah, which is why you're holding it with the tongs as well. Let's give it another shot, just to see. That's better. Now, if we put you sort of let it heat it up just a little bit more. Not much, just 20 seconds. Jack, when we do this, what we want to do is we want Tom to turn the fire off in about 10 seconds and put the whole thing in the cold water and see if it'll come through. Okay. Okay, Tom, the fire off. Hang on, make sure it doesn't fit through first. Yeah, now put it in the cold water.
Oh,
And there we go, it should go through really easily. Cool. Okay, what experiment
It's dangerous.
are we going to get the class to do to show the same idea? And it's not just, Ben, thank you. Make sure it's not just in metals, that it happens in other things.
at each station you have a conical flask and a balloon, and to stick it on you might just want to blow up the balloon a little bit so it stretches, so you can stick it over. And then you're going to heat it above the Bunsen burner and see what happens.
Cool. Any predictions for what might happen?
The balloon's going to blow up.
Balloon's going to blow up. Keegan, were you going to say something different?
Oh, no.
No, same thing. That's our prediction. Let's see if we're right.